Good morning, everyone. Welcome to another episode of Xa Talk Show. Today is June 28th, 2019. Today we're going to talk about some JavaScript. Uh, I'm thinking of coding, live coding of JavaScript. Meanwhile, let me show you some of the pages. So JavaScript, and here's Unicode. We might talk about that. JavaScript, and this is the app I did for JavaScript. Let's see, font size big, and you can create the text shadows. So we might be working on this because this page needs more work. There are many features I like to add. You can type stuff here and it will be shown in real time. There and you can change the font size. You see, if I change the font size, the whole display, the user interface changes. I mean, it moves. We don't want that. There's a technique to do that. What you have to do is to make this display box, this type element, into a layer by itself, so it does not affect the rest of the page. We want the user interface to stay, not move around when you drag things around. So that's the JavaScript we might do, and also uh, there's quite a few things. Let's see how many people are watching. One people, okay. So let me know what you like to see, okay. So let's go to Xa Talk Show and let's type out what we're gonna do. So JavaScript, and here is my Emacs softlight keys commands. So many things. So JavaScript live coding uh, interactive app. So that's one thing. Then JavaScript live coding a color converter, RGB to HSL converter, and explain color models. Okay, let me just type out the topics. So that is that, and there is also some questions I have to answer. Someone asked me a question about tech. So that is let's see, keyboard blog. So keyboard we talked about. There's nothing new in keyboard. Answer question about what to use instead of TeX or LaTeX. Okay, so these are the questions, this kind of and other stuff. Okay, and also maybe live Emacs Lisp coding. Okay, I'm gonna do that. Depending on what let me know what you like to see. Usually, let's see, let's go to back here and post here so people can see. Hi guys, so I got 3 people watching, so type comments here and let's see if I can paste that. That's too long. Let's see, paste. Live Emacs Lisp coding, and that would be modify this command log mod so it shows QWERTY keys, which means convert QWERTY to Vorak. Okay, Vorak, convert Vorak to QWERTY. You see, on the left panel, you can see all my Emacs commands, and this is done by the mod called command log mod, and I'm using a Vorak keyboard, so all the keys it shows is Vorak. For example, my home row on the left hand is AEOU, and right hand is HTNS, and does it show? And let's see. AEOU, okay, it doesn't. So anyway, so it's showing the Vorak keyboard, but most people are using QWERTY, so it would be nice if I can convert them to QWERTY. I mean, it shows in QWERTY in real time. So I'm gonna work on that if you'd like to see that. So here are some of the topics. So the topics here includes, let's type it out. The topic includes that and that and that. So let me know what you like to see. But okay, so meanwhile, show in browser. Meanwhile, I'm just going to start off by, let's answer the question. Okay, so there is this question. So there is this question. Good morning, Sean. Converting your Vorak output to QWERTY sounds like a headache. It's not much. It's not. Okay, that's a good thing. It's not too much work though. I don't think so. So you are also a Emacs user, right, Sean? So yeah, I don't think that would be too difficult. But so let me just answer this question first. Okay, so then we're gonna do, I guess, let's do Emacs then. So there's this question I got asked. Let's see, programming blog. So it's on Reddit. It's another private questions. So people, don't ask me. Don't ask me private. I mean, don't post in private forums. Okay, I much prefer public. It may be on Twitter, on YouTube comments, or go to Reddit. Slash. There's a XA fan club. Go post there, because I answer. I spend hours. For the past decade to answer questions, private questions. Like, I don't know who you are, but those people, most of these people are anonymous. They ask you questions and you answer them. 2 hours a day. It just zaps your life. And they are anonymous. Like, they are. You are not. Most of them are most of them are anonymous. You just waste your time. So anyway, he asked the question. I saw your 2019 March 25th video about talk show about tech. Donald Knuth's tech. So let's see. XA Lee tech sucks. So I have an article about tech. I talked about this a couple of times before, and why tech is extremely bad. So, and I did a video of that. And a lot of people have the same question. Basically they want to know. So tech is bad. So what are the alternatives? So the to answer that, well, there are several alternatives. I provide you a list of alternatives at the bottom here. Let's see, where is it? All the way to the bottom. It depends. So alternative depends. So if you, for example, one alternative is Mathematica. You have to pay $200-$300 for a amateur, hobbyist version, which is, by the way, identical to the professional version. Professional version is like $1,000 or something. So Mathematica is one choice. Oh, you never use Emacs. Okay, so let's not do that then. So Mathematica is one alternative. It's excellent. Okay, I'm not going to show you, but Mathematica is a great alternative, and there are several others. There is, for example, LYX. Let's open that. LYX. Now, some of these alternatives, they are just variations of tech, but they are, either variations or GUI, graphical user interface wrappers around tech. So you don't actually need to know, the tech syntax and details. It provides you GUI, but the underlying engine is still using the technology, LaTeX or tech. So some of them are tech variations, like wrappers, and some of them are variations like this XE tech here. Let me show you. So this XE tech, Lua tech. Let's show you. Okay, Loud, Tech Emacs. Those are all alternatives, and so I was saying. So some of them are just variations of a tech, like improved tech, but you still need to know the formula. For example, this XE tech, it allows you to use Unicode directly. Basically, that's what it is for. So that's one example alternative. And some other alternative are wrappers around tech. But however, some other alternatives are not based on tech at all. For example, there's this thing called GNU Tech Max. Now this is not Emacs, nor is it Tech. It's neither. Okay, it's completely. I think it's completely unrelated to tech. I think. Wait, did I? I think it is. But anyway, at least it's completely unrelated to Emacs. Okay, so there is this GNU Tech Max, and I have people who told me, who I can trust, who told me it's pretty good. So you have these, you can use these, and there are other solutions. Loud is another solution. But anyway, all these are, I don't think, I mean, they are depend. I don't think they are the. Well, I think Mathematica is the best. Okay. The other thing is that the guy actually questioned the question of this guy is actually about what is the alternative if you want to use math formulas on the web. Now that's an entirely different question. So on the web, basically you don't have any options. It's kind of sad, but that is true, because normally you can use math tech, what is called math ML. Okay, I also talked about here in the bottom math ML, but Google killed it. Google unsupported it about 3 years ago, and so basically there's no good alternatives of to type math on the web, because it's kind of sad. you know like online, like you have YouTube, and you have YouTube videos. The video technology is much more complicated than creating a typesetting system for math formulas for the web. But however, the video technology just grow and grow because people want it, because that's a major need and also a major source of money exchange, making money. That's what we need. People want to watch videos. Video technology is extremely complicated, and you have encoding, then you have the GUI system is and the data is huge. Thousands times of than math formulas. But but that's what people want, and so that technology just keep growing so much, and but if you want to type math formulas on the web, it's going nowhere because very few people want it. Not even programmers. Most programmers, you don't need it. Only mathematicians, and so basically you don't have good alternatives to the for this showing math on the web. So he says, I wanted to know your opinion on what is the best current way of integrating math in a lightweight static website blog. Yeah, there's no, and he wants lightweight. Are you kidding? There's no way. There are ways, of course. For example, if you go to Stack Overflow, or actually you go to Math Overflow, okay, or any modern website on math, or even Wikipedia. You see lots of math formulas. Let's see if I can see. Let's show some example. Yeah, okay. So let's magnify. So you see these real math formulas. You see all these formulas. They are done by basically a JavaScript library. This JavaScript library will convert, it supports several input syntax, and one of them, the most popular, is actually TeX or LaTeX. So it converts this syntax into this display. And what technology it uses depends. It may use SVG, the scalable vector graphics, or it may use MathML, which is the XML based technology to display math, which Google Chrome no longer supports. Or it can support images. It just generate images. So the input and output, you have several varieties of input. TeX formula. There's also ASCII math formula. You can use as a syntax for input. There are a few, like 3 or 4, and the output format also depends on. You can hardcore set it to using bitmap images or SVG or MathML, or a combination of them. This package, this library is written in JavaScript, of course, and it's called Mathjax, Mathjax, and it's pretty big. It's huge. Okay, that's that's their logo, and it's nowhere lightweight. It's a pain in the ass, and So anyway, so if you want to display math, so nicely like that, this is almost the only choice, the Mathjax. Uh, it's a sad state of the situation, but that's how things are. So anyway, that answers the question, this guy's question about alternatives to tech. Let's see, go back. So he says, I want to have a compatibility with the maximum amount of browsers without the client requiring add-ons. I would also like to keep client-side JavaScript to a minimum, as well as client CPU usage. Yeah, well, the only choice is Mathjax, basically. Yeah, so, and which is, by the way, it is also what Wikipedia uses. Wikipedia, it uses Mathjax, but it has several preferences. If it sees that your browser, for example, you have JavaScript turned off, then it will just generate, the math. It's still using Mathjax. It will just generate bitmapped images and display those images. So it depends on your browser. So it's just basically it's just using Mathjax. So that answers that question. So I guess let's do JavaScript then. So let's see. Okay, so if you guys, like pick a topic, otherwise let's do JavaScript. Let's see what else I want to talk about. So what's up, Sean? Anything interesting? Um, let's see. JavaScript. So there are two things to do with JavaScript. Uh, let's see. Talk show. We're gonna do JavaScript coding. Yeah. So RGB. Yeah. So one thing is that we fix this so that when we change the font size, this page, the user interface does not move position. So, and also on this page, there are more features to add. For example, I want to add, let me go through this. Let me show you. So this changes color, this, and this changes the offset, for example, and this changes the offset. And this slider changes the length. It basically changing the offset parameters x and y, but however, by using the length and the direction, you see this way is more intuitive. Instead of adjusting x then adjust y. So that is that. Then you have blur. Then here is the text box. Okay, then you can adjust the font size. So the whole thing moving around is no good. We're gonna change that. Then you can change the background color. Let's see. Let's say black. Okay, then let's see random color. Oh, then okay, so we also need another feature that changes the text color, the original text color, not the shadow. This only changes the shadow's color. You can you can see the original text there. So we need to change the original text color. And another feature, what I want is that when you design, I want these different fonts like this Gothic. That's an interesting thing. You have this Unicode Gothic font. So let's do that then. Okay, so let's do this. Oh yeah, so this is one thing. The other thing I want to talk about. Let me show you. Let's go to Wikipedia. HSL color. Okay, here HSL versus HSV. That's not what we want. We want. Let's see. Oh yeah, here. Okay, this is what we want. You see, the color model is very complicated. Originally in computing, in programming, you have RGB. RGB is like that. You have the color cube RGB. It's based on how basically the addictive color model, where you have red, green, and blue, three colors. These are called primary colors, and all the rest of the colors are a mixture of these three lights, colored lights. This is roughly based on physics, light model. So red, you have different values for red. It forms one axis. Then you have blue, another axis. Then you have green, another axis. So altogether, the color space is like a cube. So it's made of three numbers. You pick a color by choosing three different numbers. And this is one of the model of color. And the other model is called subtractive model, which is called CMKY, I think. CMKY. It's that's abbreviation for cyan, magenta, yellow, and something. Let's go there. Oh, cyan, magenta, yellow, and key. Basically, this model is a subtractive model. That's, when if you are a painter, watercolor painter, you paint and you mix paint. You mix yellow and magenta, you get red. That's how that model works, which is which is different from the RGB model. If you in RGB model, if you mix yellow and magenta, you don't get. Do you get red? I'm not sure. But anyway, it's different. So anyway, let's go back to the red, blue, green model. So this is interesting, but there's one problem with this model is that it's not intuitive because um, let's go to math notation, past and future. Uh, yeah, for example, let's see, we have a color box here. Let's refresh this page, get back to default. Then let's see a color. Let's say big font, lots of blur, and color. Let's pick one color, red. Okay, so we got this color. Uh, let's see RGB. So you can see different color models here, RGB sliders, red, green, and blue. You see, it's not intuitive. Let me move that here so you can see. Actually, can you see it? So you see, you have these three sliders: red, green, and blue. You see the red part, it becomes um, I mean, the point is, if you want a color yellow, like how do you choose red, green, blue, and it's not intuitive. So in this case, if you want yellow, blue must be 0, I guess. Red and green must be maximum. Then you get yellow. But now the red bar, you can see it becomes, it's not intuitive. So that's why they created a different model, HSL model. Now let me show you the HSL. Color names, color syntax. So this is CSS. This is the HSL model. You can see you can adjust the hue. The hue is let's put the saturation to max. The saturation is how much color you want of that particular color. The hue is like a rainbow wheel from 0 to 360. Let's put a lightness. Let's put the lightness here. So you can see the hue is red, orange, blue, green, purple, violet. It's like a rainbow. Then for each color you have saturation, like how much pigment you want of that color. Then you have lightness. It changes to bright to dark. So this way, this syntax is more intuitive. You got three numbers. You can tell just by look at the numbers what color this will be like. But so this is called HSL model, hue, saturation, lightness, and you can see examples here. This is change of hue, this is change of saturation, and here's a change of the lightness. That is one of the model. This HSL model is invented after the RGB. The RGB is based on physics, but it has the problem of not intuitive. So people, engineers invented this HSL. And by the way, there's another model which is similar to HSL. It's called HSV. Okay, HSV is kind of similar. It's used in Mathematica, by the way. So on the left, you see this picture is a HSL. On the right, this picture is HSV model. They are kind of similar, but the interesting question is that how do they, color is very it's a huge science. Color is actually a huge complicated science. You can study, you can get a PhD degree for it. There's a aspect from physics, then there's aspect from engineering. Then there's aspect from human perception. The biology of the eye, which is different from just physical measurements of the light waves. Physically, color are different length of waves. That's how we perceive it. So in a sense, our eyes is a machine that can perceive, that can detect wavelength differences of certain wavelength. That's how we perceive color. So in terms of physics, color is just a different wavelength. It's something like that. But then the human eye, the mechanism and our perception, that's entirely different thing. It's not just detecting wavelength, because we only detect certain wavelengths, and for certain, it's particular to our brain, to our perception. For example, we say that dogs and cats, they don't see the same thing as we do. So there's a human perception aspect. This is important because if you just model color by physics, that's what not you see. You can only see certain limited things. So everything, all the colors you perceive, that's human experience. It's not, you might have some colors humans are not able to see. Like you have infrared or ultraviolet. Like you have these ultraviolet lamps, like black lamps or something, things like that. You have to shine a particular special light in order to see it. So so the biology of the eye is actually quite important. When you want to design the color model, you want to design a system that specifies color, such as the CSS, RGB, and HSL. So there's a physics aspect, there's a biology aspect of our eye, and that ties to psychology as well. Actually, you see many illusions where they have they have a background color, then they have two boxes of the same color, but you see this one as black and you see the other one as white, but actually they are the same gray. Because their background is one is white. That's illusion. So it has to do with psychology as well, not just biology of the eye. It's tied together. So the biology aspect, psychology aspect, but there's also engineering aspect, which is very complex. So what do you mean by engineering aspect? For example, when your TV or monitors display colors, but however, they cannot display perfectly all the colors, because the display system is created by we have different technologies. We have electronic beams, or we have LCD. You have LED lamps behind the screen. All kind of different technology, quite a lot. There's a lot projections, projectors, different type of displays. So they are, when you tell them your TV or your monitor or your phone to say show red color, they actually all show different kind of red. So because the technology is different, and they have different capabilities. So that is why. So this is the aspect of engineering. This is actually quite extremely complicated. So that's the display system, but there's also the capturing system. For example, photography. You have your iPhone or camera. You take a photo of something. It records. It records the lights of the scene at the time. But how does it record? Suppose I have a different color of red here. Suppose I have a rainbow. You take a photo of a rainbow. What does it store for red, for example? How it stores the red color. So that's technology, and it again depends on what depends on if you are using old style camera, film. That's one way to record it. If you have digital camera, that's another way. So it's very complicated. And also you cannot do it perfectly. We are engineering is almost always make do. Um, Trying to find what's the best way. So you have all these different complexities. Physics, engineering, biomechanics, and we are trying to design a color model, so it's actually very complex. So but back to our topic now. The question is, so you have this HSL model, and you have this RGB model. You see, RGB model is based on physics, light waves. But where does the HSL model came from? I mean, how is it invented? Like when you use like for example the hue, it's a rainbow color, but how do you actually convert it to RGB? That is the question. How do you convert these three numbers to RGB? So if you look at this in detail, you can see it's not intuitive, it's not natural, it's actually very complex. By the way, I wrote a converter in Second Life long ago. Let me show you. This is interesting. Xali Second Life particle system. So I wrote this application, this 3D interactive application in Second Life. Okay, particle maker. Okay, here's the one. I spent a month to create this. Now, if you don't know what Second Life is, let me show you. So anyway, so this is the XR particle maker. Okay, you have to pay for it. You have to buy it. It generates code for your Second Life stuff. Uh, I spent 1 month, more than a month, to create this, and I sell it for like I think it was $20 USD each US dollars. So Second Life is basically it's like a 3D game. It's a virtual world. Okay, I spent like 4 years in it. So anyway, I created this particle maker. So what is a particle? Particle is in gaming, 3D graphics technology. You have to use this thing called particle to create things like rain, fireworks, snow, smoke, or water. This kind of thing. Because this kind of thing, they are not polygons. For example, hair, you cannot model them as polygons. So you use this technology called particles. So what exactly is particles? Particles is quite funny. Okay, it's a hack. It's a hack. Basically, it's just images, like what you call sprites in gaming community. It's basically two-dimensional images, and you have thousands of them floating around your screen, your two-dimensional screen. So the ultimate effect is that they appear as like rain or fireworks or Let me show you some of the graphics gallery. Let's see. Gallery. Okay, let's open that. So here you have like a huge smoke, or fog. Here is the rain. Here is some kind of artificial particle. You see stars. These are in real time. If you go into Second Life, just like any game, you see them in real time. And here's the artificial ring of stars, and this is kind of like a laser show, and this is kind of like a volcano, volcano dust. And here is another example of some kind of neon show. So, but anyway, all these are made of particles, and they are essentially they are just images, two-dimensional images, like thousands of them floating around your screen. With the purpose is to emulate these kind of things in a virtual world, in a 3D graphics. So in order to create this, I have to write color wheel, and I have to write a function that converts HSL color model into the RGB. When you do this, you find this very interesting thing. When you write the algorithm to convert it, because you realize the color models are extremely complex. Now, um, if you use Photoshop, or you looked into arts and color, you must have seen this. You got this very complicated um thing to understand. So that's what color are, a very complicated thing. So I was saying, so I have to write a converter from HSL to RGB. Then you realize, okay, here is what it looks like. Okay, these let me show you. Um, so this is what this algorithm, the result looks like. It looks, basically, you see. So when you have HSL, where is it? Let's see. So let's see how many people I got watching. 4. Okay. So when you have the yeah, where is it? Here. Yeah, here. Here. Where is my application for? Okay, so yeah, here's the HSL. So when you have the HSL color, you got these three numbers. You want to convert to RGB. So it's very strange, because when you increase the hue, you can see the RGB sliders goes haywire. Like when you increase the hue to a certain point, the RGB, some sliders goes backward, some goes forward. And the way they move is like this, in this picture here, from Wikipedia. It's like this triangle. So anyway, so what actually is it doing? So the question is, how is the HSL created? How is the model of HSL model created? Where's my pages? Yeah, so the HSL model, they are created by, you can read from this Wikipedia article. They are created by like this. Let me show you. Okay, so you have this. So you have this RGB color space, which is a cube. Okay, now um, you turn the cube so that the verticals are at the top. Let me try to find a cube. Do I have a cube here? I don't think I have a cube. Uh, Okay, I'm trying to find a cube here. I don't have a cube, but but anyway, let me show you other things. Okay, interesting things. Xali, hyperbola, hyperboloid, hyperboloid of one sheet, and hyperboloid of two sheet, and hyperboloid architecture. These are all very interesting things. So hyperboloid is a mathematical structure. It looks like this. It's a surface. It's what's called a ruled surface. And it's created. One way to create it is like this. You have a bunch of lines. You just put them in a cylinder. They just twist. They are basically made of lines. Uh, a line in an inclined position, and you revolve it around a circle. You get this. Depending how the line is twisted, I mean how the depending on the angle of the line, you get different shapes of the hyperboloid. And sometimes you can see a basket made out of it. And this you can also do at home by if you have pasta, you put them into a jar and you shake, you rotate you shake the jar in a circular fashion. Then you get this hyperboloid. Okay, so it's a model. This is a surface called hyperboloid. And by the way, this picture, this is in Second Life. So I created this in Second Life back in 2009. So hyperboloid, it's interesting. So this video, let's watch it. It's kind of not intuitive. You have this line, it can go through this shape, this curved hole. So anyway, so that's hyperboloid. Okay, so what about it? So the interesting thing about it is that if you have a cube, like a dice, and you rotate the cube on the tabletop, the profile of the side is a hyperboloid. So that's why we are talking about this cube. I don't have a cube here, so I cannot show you. But if you have a cube, oh God, I need a cube to demonstrate this. But anyway, if you take a cube and you put the corner on top and the bottom, and you rotate the cube, you can see if you have dice somewhere, you can see it form. It spins like that. If you spin the dice, uh, so that's hyperboloid. So I think we can go back to the color thing. There are other things called hyperboloid. This one is called hyperboloid of two sheet, and then we have hyperboloid in architecture. These are huge chimneys, nuclear reactor chimneys or power station chimneys. By the way, they blow out steams. Those are not smokes. Those are not carbon dioxide. Typically, this kind of chimney, they blow out. Those are steams, like water steams coming out. But anyway, so let's go back to the color cubes. So I was saying, if you take a cube and you put the corner at the top and bottom, then you have this 1, 2, 3, 4. You have 6 other. A cube has 8 corners, 4 on top and 4 on bottom. 8 corners total. So if you put the cube, you positioned it. So one of the corner is at the top and the other corner is at the bottom. Then you have 6 other corners. They form a hexagon. So that is when you see this picture. Let's go back here. So that's why you see all these triangles showing up okay, there's a picture here. So you put a cube, then you see you got a hexagon. And so now what? What was I going to say? Uh, okay, so this is yeah, they got a picture here. So this is how you transform the RGB cube into the HSL model. So you turn the cube, then you got this kind of hexagon. Then you just trim it. So this is the HSL model. So from this, you can understand how the HSL or HSV came from, and how the numbers actually work. Like you have a point in this, cone shape or hexagonal cylinder shape. You can see how they correspond to a point moving around in the cube. That is why when you move a point around this HSL model, the parameters of the RGB changes in a erratic way. So anyway, that's what I want to mention. But we are going to do some um, coding of JavaScript. Shall we still do that? Yeah, I close the window. I got 5 people watching. So yeah, let's do a small one. Let's create a shit. I don't have my drinks anymore. Yeah, let me get a drink, and let's do the JavaScript coding. So I got a drink of the. So this is what they call it ban, but it's just like energy drink, Red Bull. Energy drink, cheap energy drink. It's like Red Bull, but sugar free. Then today I got this ruby juice, 100% juice. I see my name mentioned on one of these 4chan image boards. Let me let me show that. Let's see google.com. Okay, let's go to Google search. So Google search Kasali. Okay, and you see these people talking about me. They do that often. Tools times. What is this? Search performance for this query. Last 28 days. See ways to improve. This Google. Oh, visible only to you. This Google scum. Anyway, so let's go to the past 24 hours. So you see, these 4chan people, I got mentioned there quite often, few times a year, and that's a picture of me when I was like, that picture is from 2002. And they talk random things, about my stuff. About I got this uh, page. I got this web page that becomes extremely popular. Um, it's on Reddit or Hacker News every now and then. Why tiling window manager sucks. Xmonad, rat poison, DWM, and stuff. And these people, this they talk about it all the time. They these people are kind of nerds, and they are kind of like fringe of society. That is the reality. They are kind of the fringe of society. um anyway, um so in this article I'm talking about efficiency of operating your computer. But anyway, let's go back to let's do the JavaScript. Let's just add a font. Let's say I want to create a new font. So let's go to here. Where do I want to add it? I want to add it before the font size. Okay, so search for font size. So okay, copy that, paste, and uh, let's say font. So choose a font. Okay, so we want to let users to choose a font. In order to do that, we have to think about what kind of interface you want. Obviously, it's not a button, it's not a slider. So what is it? So let's go to DOM scripting. DOM scripting, and let's go to HTML input. And in the case of choosing a font, we can either use a radio button, which give you several choices, or you can use a pop-up menu. I prefer radio button because radio button everything is laid out. You don't have to click and see what are the choices. So let's use a radio button. So in order to do that, we just basically just copy the code here. Okay, font. So font, we have these choices, and radio button. So what choices? So first of all, the name will be font. Let's say font box. Font select. Okay, and the value will be, let's say, serif. Sans serif. Okay. Then monospace. Show in browser. Okay, we got font, serif, sans serif, monospace. That's good. Let's prettify it. Okay, let's add some more space. We need some more space. That's good. So we added this user interface. The next thing to do is we need to modify the JavaScript. So there's some action when people click on that. So copy it. So let's open the JavaScript file. Open it. Font select. So how do you use JavaScript to get the radio button? Let's go back to lookup. Oh, it's just repeated here. Let's go back to look up the radio button code here. Let's just copy it. So go to the JavaScript code and let's go to the top. Let's paste at the top. We want show box. We don't need. So basically, the only thing you need is these lines. Let me show you this line and this line, and the name will be, the name was font select. Let me show you what it is. Okay, so first of all, you need to get a you need to define the element. Okay, we define the element like here, font select. Okay, and by using the query selector, we want to select all input whose name is font select, and let's forget about that checked. And okay, that we don't care. So this is what we want. We just want to get all the elements of the name font select. Okay, then we need to add a event. So array from, so font select, the query selector actually returns a not list, which is not an array. So you need to turn it into array if you want to use array method such as for each. But actually today's browsers, they have built in, they made it so that for each you have the for each method without needing to convert the the not list into a array. They did it by hack because it's quite a mess. So this is one of the problem of the web spec and DOM scripting, because DOM is extremely complex, and there's no logical reason to it. Over the past 20 years or 30 years, they just it shifts. The idea of thinking what it should be, it shifts. DOM originally stand for document object model. Today it doesn't stand for that much anymore. And originally it was designed to be, DOM is thought to be like a generic interface of any hierarchical document. You can, with DOM you have the model, then you can implement a programming language to control the document. That was the original thought. But pretty much it's used only in JavaScript mostly. But anyway, it's very complex. So anyway, the one of the extreme stupidity is that when you use one of the selector like query select, it returns, depending on browser and depending on what year it is. Sometimes it returns a not list. Sometimes it returns a HTML element collection. You can see the problem if you go to my DOM scripting tutorial. And here get element by ID, by tag name, by class, by CSS selector, and and some of them returns, for example, some of them returns a element object. Some of them and some of them are live, some of them are not live. Some of them returns a HTML collection, and some of them returns a not list. For example, get elements by name returns a not list. So it's extremely confusing. And this, if you look into the detail, there's no good reason for it. It's just history, and you cannot make sense of it. So what can you do? In practice, you don't ask why. You just code whatever works. So anyway, the problem with both when they return, so if you go near the bottom, there's an article about what is HTML collection versus DOM list. By the way, both of them are not arrays, which is extremely idiotic. Like for every programmer, when you want to get a collection of elements, the one most obvious thing you want to do is to apply a map for each, apply an array function to it. but but they don't they but their type is not array, so you cannot do it. So before JavaScript 2015, you have to do this extremely convoluted way. Let me show you where. Um, Array like object. Yeah, so anyway, so it's very complex. You have to, this complexity involves JavaScript as well, because JavaScript arrays is extremely bad. So anyway, let's just get back to the. So yeah, so anyway, I was saying, so HTML element, HTML collection, and the not list, they are not array elements. So if you want to call an array function such as for each, you have to either convert it to array first, like by calling array.form, which is, this function is added in 2015, or you can do it in this complicated way by calling array.prototype.foreach.call. That's how you call a array method on any object that is not array. And typically you do this for array like objects. There in JavaScript there's this thing called array like thing. Very complex. So anyway, that's what you have to do. But then in DOM they added, because this is a common need. Everyone, when you get some bunch of collection of elements, the first thing everyone needs to do is to apply an array method for each, to it. But you cannot, so that's a problem, and people has to resort to these ways. Before 2015, there's no proper way to convert array to array, array like object to array, true array object. You have to, so it's very extremely complicated, and it's a problem. So then in 2015 they added array from, which is one simple way to convert array like object to array. But still, that does not solve the problem, because every time you call query select, then you have to do a conversion to array before you can actually call for each. So the browsers began to add the for each element to the not list, or let's see, to this. For browser began to add it. So in HTML collection you have for each. No, you don't have for each. But in not list, if it's a not list, then you have the for each method. And the way they do it is very complicated, because for each is an array method. When you have a not list, you have the for each method, but actually it's not from the array method. It's actually just browsers just added it. They just do it. So if you have a not list, you have the for each method. Now you don't have to convert to array first. But however, if you have HTML collection, you do not have the for each method. So the whole thing is extremely convoluted. It is fucking their ass, these fuckers, these programmers, these standards, these whatever hackers, they scum. It's one thing that technology always have bugs and problems. That's understandable, but But these elite programmers, like they tell you, oh, we open source or follow standards or follow what the fuck group or HTML5 group or whatever W3C standards or um, RFC. They don't understand. They don't understand why it's all fucked up. So we just got this situation. And that's not all, because this HTML collection and not list. So in JavaScript 2015, they added a new thing called iterable, which is very useful. Okay, so they added a new iterable thing. So now in browsers, both HTML collection and not list are also iterable objects. Okay, so yeah. So anyway, it's extremely complicated. Um, I could go into the technical detail. They are iterable objects, but they are not actually iterable interface. I don't think so. I'm not sure. I haven't looked, but I don't think so. So in other words, it's just another extreme hack. So anyway, so here let's go back to our thing. We want to add a font selector, radio box of font, and so we already did that. Um, so we have the radio box to select font. Is it here? Yes. So sans serif, and monospace. But now we need to add a interaction to it. So we add the element font select. Now we need to add a event listener. So event listener is at the bottom of this page, my JavaScript code. Event is at the bottom. So we add a event, let's say here. So you go through the font select thing, and for each element you add an event listener. Yeah, and whenever it's changed, you call the function update f update. That's right. So now let's modify the f update code so that it actually changes the font over here. So in the f update code, let's see, font size, font, it's so font select. So here what we want to do is this font family. So we want to change the font family to the value of font select. That's right. And how do we get the value of font select? It's not dot value because it's a radio box, so it's not dot value. It's rather dot checked, one of the radio box that is checked, and you want to get that item's value. So how do you do that? Let's see. So we need to go back to the DOM radio box. So radio button. So here is the code. Copy it. So paste the code here. So selected value equals to, here is how you get the checked, that there. So then once you get the value, you want to convert it to string. That's right. toString. Okay, this I don't need, so let's put it here. That's right. So shadow box is the display area for it's over here. So shadow box style dot font family equals to the selected value of the font radio box. Okay, that seems to be it. Compile the code. This is TypeScript. Okay, so some errors. I know what those errors are because when you code TypeScript for a while, okay, there's some mistake here. Query select font. So you need to add here HTML input element to cast a type. Okay, then let's compile the code again. Let's do it again. Property value does not exist. Okay, line 77. Now I also know why, because this is one of the problem of using TypeScript HTML input element. Okay, that's what you need to do. You need to cast the value. Let's compile again. Oh, okay, so we actually should be like that. Compile. This is for some reason taking a long time to compile. Normally it's not like that. Oh, you need to put a parenthesis. Compile again. Okay, we are getting somewhere. So it says that element, this is line 109. Now 109 over here. So it says this element is not assignable to parameter of type array like. Why? Not assignable to parameter of array. (109) position 22. So this is argument of type is not assignable. Okay, font select is not a HTML element. It's actually a not list. Let's see if we can, maybe that works. Let's just forget about that. Those errors, let's ignore it now, because TypeScript is a superset of JavaScript, so it spits out these errors, but let's ignore it. Let's go back to browser, refresh. That is working actually. Let's increase font size. Okay, let's pick serif, sans serif, monospace. No, it's not working. So let's go back to the HTML page. Sans serif needs a let's go back to open update. Let's go to the update function. So font family equals to selected dot value dot to string. Okay. Font select. Let's show the browser console. Refresh. So what is going on? So let's print the value and see. So we want to print the value. Let's see. Compile it. Refresh browser. Okay, each time we click on that, there's no effect. And it's not calling the update. Because if it is calling the update function, it should print here. So we know the problem is with events. Array from font select. Font selection. So we're trying to solve this problem. So select all items that's named font select. Okay, so which is over here, font select. That's right. So you select those items. Oh, the value here is the problem. It's one of the problem at least. So the value should be sans serif, and let's go back to, so let's go to the update section. So checked value, the value is already a string, so I don't think you need two string. So font family equals to, compile it. Okay, let's fix this. Font family. Now what does it say about style? Let's say inspect font size, font. So you see, font family is actually working. I mean, you can see the style here. Font family is sans serif. Um, Wait, but where does that sans serif came from? I think it came from my browser. I mean, my style sheet. But anyway, why is the event not working? So we selected for each one, add event listener, input, and f update. Let's print font select. It's checked sans serif. Oh, okay. Yeah, you are right. You are probably right. Okay, anyway, I'm a little bit confused here. Anyway, so let's go back here. So it's printing, right? Yeah, I know. So right now we are printing out. We are printing out the element. Now this is supposed to be a list of elements, but however we are only printing. It looks like it's only printing one item. You see, we are printing the font select here, and this font select is supposed to be, it came from here, and this is supposed to be, oh, query select. Got it. I know it's why, because because the HTML selection, let's go back to DOM. You have two different, you have query selector and query selector all. It's very confusing. So over here we need the query selector all, not selector. That's right. That's why the TypeScript is popping up with the errors that for each, not found or something like that. Okay, now it succeeds without any error. So let's remove the console log. Remove the console log, and hopefully, everything will just work. Let's go back to, so go back here, refresh browser, bigger font, serif, yay, sans serif, monospace, yay. So we got that working. Actually, yeah, so that's great. So there's one more thing, celebration, yeah. There's one more interesting thing is that I want to show this Gothic font that's very fun to have, but it's actually not a font. Uh, Let me show you this. This is called mathematical font. Well, it's not font, but it's just Unicode characters. So you go here. So you have this, this Gothic, or like New York Times logo. These are technically called Frankter letter font. So, but anyway, these characters are not actually font. For example, if they are just Unicode characters, for example, I copy them. Oh, Germanic typeface, yeah. So I copy them, I paste here, and I magnify. You see, these are the characters. And now if I call describe character, you can see this character is called black letter capital C. it's a character. It's not it's not like a character plus font. You apply a font to it, but rather this character represents the capital C with the font already. So there's so that's an interesting technique to yes, self-contained unit, yes. So let's add it here, to our page. So just for fun, let's go to the text area, um, text area. Okay, let's add it here. Okay, and refresh the page. Okay, let's see, font size large. Okay, let's see. Blur. Let's turn off the auto. So yeah, so what, there's more things I need to fix, but I'll just go offline and do it. You see, when you increase the font size, it goes over. That's no good. It also, it changes the position of the all the sliders. That's no good. So what you want to do is you want to use CSS to make it a different layer. I'm gonna, if you are wondering how to do that, you can go to the here, layers and layout. You want to create a new layout. I mean a layer, so that here, create a layer. Using CSS so that it actually doesn't interfere with the rest of the page. And I also need to add another font choice so that it shows the Gothic, because right now if people type if they type something, then the Gothics, those functor letters are gone, so there's no way to get them back. So anyway, that's some of the things yeah, hide and flow, that's also nice to do. That's also a solution. So yeah, anyway, I think that's it for today. I kind of like talked about random things a lot. So any more questions? So I'm thinking, actually, I've been thinking maybe I'll do another one on Emacs later today, but I'm not sure because um, so anyway, thank you guys for watching. Bye, Sean.